So far, we've only looked at working out the trigonometric values for angles from 0 to 90 degrees. So if we take the sine function, for example, here, you can see that it runs from 0 round to 90 degrees. And that's equivalent to going from this point here to this point here on the sine curve. Now this is called the first quadrant, because it's the first quarter of our circle. But what happens whenever we move outside this quadrant? How do we work out the value for the sine function for angles which are greater than 90 degrees? Let's say we continue round into the second quadrant. So now we have a much bigger angle. So this is the angle here, from this point here all the way round to this line here. So this angle is greater than 90 degrees. Now we can already see what the value of the sine function is for this large angle, because we have this point here. So the value is simply the height here, which is 0.704. Now this large angle here, you can see, is actually 135 degrees. But if you notice here from the symmetry of this function, you can see that this point here is going to be the same as some other point just over here somewhere. So let's map that point out. So you can see that this height here is the same as this height here. And this angle here is 45 degrees. So it means that the sine of 135 degrees should give us the same value as the sine of 45 degrees. And it should be somewhere around about 0.704. So let's put these two values into our calculator and see if we actually get the value 0.704. So let's put in the sine of 135 degrees. And you can see the actual value we get is 0.707. So let's clear that and we'll put in the sine of 45 degrees, and this should be the same. And there you can see we get the value of 0.707. So we could draw a line joining these 2 points. And you can see that line there is going to go from the point given by the white line, which is the angle 135 degrees, and the point given by the blue line, which is the angle 45 degrees. And if we continue this along, you can see it's going to go all the way along to the point on our radius, which is rotating around the circle. So we can rotate this here, and you can see that for each of these angles in white, they have another angle here in blue, and the sine of each of these angles will give you the same number, which is just this height. So we can generate a nice little trigonometric identity for these sets of angles. So we can say that the sine of theta is equal to the sine of 180 minus theta. And from the previous example we looked at, we can see that the sine of 45 is equal to the sine of 180 minus 45, which is the sine of 135. Equally, we could turn it round the other way. We could say the sine of 135 is equal to the sine of 180 minus 135, which is the sine of 45. So we have this nice little trigonometric identity that we can use. Now let's see what happens whenever we move into the third and the fourth quadrant. We will now work from 180 degrees round to 360 degrees. So you can see here that the radius is starting to rotate round, and we have the large angle round here, and we have two values for our angles, and the sine of these angles are equal, and they're given by the heights here. So that's it worked its way around to 270 degrees, and it will continue round to 360 degrees. So now let's rotate in the clockwise direction from 360 degrees round to 300 degrees. And you can see here that we have gone from the 360 degrees, which is this point here, and we've rotated round in a clockwise direction until we get to this point here, which is an angle of 300 degrees. So in effect, we have taken off a value of 60 degrees. Now, if we were to put in the other value here within the first two quadrants, you can see that the height of this value here is going to be the same as the height of this value here. The only difference is that one of them is going to be a positive value and the other is going to be a negative value. And you can see that happening as we move this along. So these are going to be the same height, but one is going to be a positive and one is going to be negative. Now let's rotate the phaser in a clockwise direction. So we're going to go from our 360 degrees, in this instance, round to 300 degrees. So you can see here that this white line here exists at a point which is 300 degrees, and that's equivalent to this large angle all the way around. So by definition, whenever we rotate in the anti-clockwise direction, we get a positive angle, and whenever we rotate in the clockwise direction, we get a negative angle, and this is purely by definition. So in this example here, we've got this point here, and this point here is equivalent to rotating it in the anti-clockwise direction by 300 degrees, and it's the same as rotating in the clockwise direction by a value of minus 60 degrees. Now let's compare the height here of the angle 360 minus 60 and the angle of 60, which is this height here. So this is 60 degrees here, and this one here is 360 minus 60. And you can see here that the heights are going to be the same, so that's approximately 0.867, and this one here is approximately 0.867. But one is positive and one is negative. And you can see as we move this round about, you can see that the heights are actually going to be the same, but one of them will be positive and one of them will be negative. So we've said that the sine of this angle here, theta, is going to be the negative of the sine of the angle 360 minus theta. So we can write this out as an identity. So the identity here is minus the sine of theta is equal to the sine of 360 minus theta. But all this is telling us geometrically is that this height here is going to be the negative of this height here. And this height occurs at the angle theta, and this height here occurs at the angle of 360 minus theta. And you can see this as we move the angles. Now there's one more identity that we're going to look at in this video, which follows directly from this identity here. Now you can look and see that the angle here is angle minus theta, but this angle here is the angle of positive theta. So we could say that the sine of this minus theta is the same as the minus the sine of the value theta. And we can write this identity here. So all we're really saying is that this height here is going to be the negative of this height here. And this angle here is going to be the negative of this angle here. So we have minus sine of theta is equal to the sine of minus theta. And again, this follows directly from this identity here, because the value of 360 degrees is the same as the value of 0 degrees. They're the same point on the circle. So we can take the 360 and replace it with a 0, and we're just going to be left with 0 minus the theta, which is just the same as minus theta. So this is our third identity, and our first identity, which we seen earlier, is this sine of theta is equal to the sine of 180 minus theta. So we've seen three different identities here involving the sine function. Now, there are more identities involving the sine function, and we have identities also for the cosine function and for the tan function. But all of them have the simple description that we've seen here in common. And you can work out all of the identities for yourself just by drawing out this circle and looking at the symmetry of each of the curves. Now, if we head into Google and type in trig identities, and we head into the list which is within Wikipedia, and I'll run down here until we get to the identities, and that's this table here. So I'll make that a little bit bigger so we can see it. So the identities that we have looked at are the ones on this line here. So we've seen that the minus sine theta is equal to the sine of minus theta. We've also seen this one here. Now in this instance, the values are in radians, so the pi represents 180 degrees. So this is the sine 180 minus theta is equal to sine theta. And the last one we looked at was the sine of, in this case here, 2 pi is 360 degrees. So that's sine of 360 minus theta is equal to minus the sine of theta. So we've looked at these three here, and you can note that there's another couple here which we haven't covered, but we will cover those in a different video. And you'll note that we got the same for the value of our cosine function, and we've got the same set of identities for our tan function. We've also got identities for the reciprocal functions, but we haven't looked at those yet. But remember that all of these identities can be generated from that simple circle and looking at the symmetry of our functions.